Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at limits. So when we're asking about limit, what we're really saying is the value that a function approaches as its input approaches some values. So for example, the limit of x approaches 2 of x squared minus 4x plus 5 is saying to what value does this function approach as x gets closer and closer to 2. Now this is a really easy limit to do. We can simply substitute x for 2 into here, and the value would be 2 squared minus 4 times 2 plus 5. And that, of course, just equals 1. So as x gets closer and closer to 2, this gets closer and closer to 1. Now, I just wanted to make a note that sometimes you'll have limits with multiple variables. Now, in this limit, we're only looking at the limit as h approaches 0. So x doesn't depend on h. So when I'm substituting h for 0 here, I just kind of leave all the x's alone. So it's x squared plus x. Now h is approaching 0. So I get this, which just equals x squared, because anything with an x in it doesn't depend on h. So this example will be a little more challenging, and the reason is it shows that we can't always simply substitute this number into the function. Here we can't substitute h for 0 because then we would have a division by 0 error. So when such a problem arises, what we need to do is we need to algebraically manipulate this. We need to find an equivalent expression into which I can substitute h equals 0. So let's divide top and bottom by h. Now 4h squared divided by h just gives 4h. 3h cubed divided by h, we'll get negative 3h squared. 6h divided by h is 6. Now we actually haven't substituted anything, so we are still needing to write limit as h approaches 0. These two expressions are equivalent, except you can't substitute h equals 0 here, but you can here. So substituting h equals 0, we just get 6. The final answer here is 6. So let's look at this one here. So we're taking the limit as x approaches 0 of this function of x, but again, we can't substitute x for 0 because then we would have a division by 0 error. So we're going to manipulate this function. So what we're going to do is we're going to combine top and combine bottom into a single fraction. So the top becomes x plus 1 on x. So what I did there is I changed this to x over x so that I could add the two fractions. And similarly, I'm going to change this to 2x over x. So the bottom becomes 2x minus 1 over x. Now, I can get rid of these two x's. Now, because I haven't substituted anything yet, I still need to write the limit as x approaches 0. See, I can now substitute x equals 0 here because I won't get a divide by 0 error. On the top, I'll just get 0 plus 1. On the bottom, I'll get 2 times 0 minus 1, which is negative 1. So the final answer there is just negative 1. All right, let's look at an example of where a graph can help us with limits. So here I have the graph of y equals 2 over x minus 2 minus 3. Let's look at the limit as x approaches infinity of this function. So as x approaches infinity means what is happening to this function as x just gets larger and larger. So we can see from the graph that as x gets larger and larger, y is just getting closer and closer to, but doesn't actually equal negative 3. So even though this graph will never equal negative 3, even though it will never hit this asymptote, the limit is still equal to negative 3. See, what happens is as x gets larger and larger, 2 divide a really, really, really large number gets you close to 0, so y is approaching 0 minus 3. So negative 3 is the limit, even though the function can never actually equal that value. All right, what would be the limit as x approaches 2? See, here we have a bit of an issue. As x approaches 2 from the right-hand side, you can see y, the function, is just getting larger and larger. But when x approaches 2 from the left-hand side, y, the function, is getting smaller and smaller. So we write it like this: as x approaches 2 from the positive or the right, the function is getting closer and closer to infinity. And similarly, as x approaches 2 from the left, so that's what that negative means, this function is getting closer and closer to negative infinity. We actually say that the limit here as x approaches 2 doesn't exist, or sometimes you might see it called a one-sided limit, because it's not approaching, the function that is not approaching the same value from the left and the right. All right, let's now look at limits using your calculator. So here we're going to look at the limit as h approaches 0, 4 to the h minus 1 over h. See, this is not an easy limit to figure out. We can't substitute h for 0 because once again we will get a divide by 0 error. Now it's not easy at all, even if there is a way, to algebraically manipulate this. So sometimes we just need to use our calculator. See, this is saying what happens as h gets smaller and smaller. So what you can do is try smaller and smaller values for h. So if you substitute h equals 0.01 into this expression, you get 1.3959. Okay, now let's try a value that's even smaller. Let's this time try h is 0.001. So putting that into our calculator for h, we get about 1.38726 blah blah blah. Now we can try an even smaller value for h. And what we end up getting is it's about 1.38639. Now we can keep performing this process up to a point. If you, however, choose a number that's too small, like let's say this number with heaps of zeros, you will run into a problem because your calculator only has a certain number of digits to which it's accurate, so it might not be able to distinguish a number like this from 0, and of course we can't substitute 0. So you have to keep picking small numbers, but only up to a point. Now if you keep going with this process, you'll see that what happens is it gets closer and closer to the number 1.38629 and so on, which happens to be natural log of 4. So sometimes there's no way to algebraically manipulate it. If we were to graph this, we wouldn't be able to see this number clearly on the graph. So sometimes we just need to use our calculator to try progressively smaller, or sometimes larger, values of h into the function. But we have to be wary that our calculator is only accurate up to a certain point. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.